Today we're going to take a look at the law of cosines, and like the law of sines that we did the other day, this can be used for non-right triangles. So let's see here. Let's bring this up. Oops. Can I get back there? Sorry guys. Where did it? Oh dear. Alright. So here we go. Now we're from the beginning. So this is another one that we can use for non-right triangles. It cannot be used on right triangles. And we're not going to go through the derivation of this like we did with law of sines, but here if we want to find a side, then we add our other two sides squared minus 2, those same two sides, times the cosine of c. So the thing to remember here is if we were to find little c, then it's the cosine of c that's on the other side. Now this can be switched up too. If we wanted to find side b, then it's going to be a plus c squared minus 2 times a times c times the cosine of b. So the letters don't matter, it's just whatever side is over here, it has to be the cosine of that angle. And you always want to find the largest angle first. So we're asked to find this triangle. So you can see how we can't use law of sines here because we don't have an angle and the side opposite. So we want to find b. So b squared equals 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 120. And since we have everything here, we can just type this all into our calculator here. So 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 120. So we end up with 151. And then we take the square root of that. So square root, I can just arrow up to grab that, 12.3. And now once we have an angle on the side opposite, we can use that law of sines. So the sine of 120 over 12.3 equals, we could find a, so the sine of a over 9, multiply each side times 9. So we can figure out what the sine of a is. So we have the sine of 120 divided by 12.3 times 9.634. And then again, to find our angle, we'll do that inverse. Alright, so trig inverse, I can just go up and grab that. So we have 39 degrees. And then if A is 39, let's see, well 120 plus 39, we have 159, so this is left to be 21 degrees. Now we're going to look at one more here, well, using this law of cosines here. So on this next page, let's see here. We have to solve the triangle. So it looks like A, B, and C. So little a is 24, B is 40, C is 18. So we can see here we can't use law of sines. So once again, which angle should we find first? Well, it's the largest, so that's going to be B. So if we're going to have the cosine of B over here, then we're going to start with little b on the other side. So 40 squared, and then we have our other two sides, 18 squared plus 24 squared minus 2 times 18 times 40. And now you just have to be careful solving this one. So we got 40 squared. So we have 1600. And now we can combine some of this. Sorry about that, we'll erase that. We can combine, well, we add here. Some people are like, well, why can't we type this all in? Well, this is all multiplied together times that. So we can't just combine those because this is multiplied with that cosine there, but we can do 18 squared plus 24 squared, so 900, minus 2 times 18 times 40, 1440, times the cosine of b. And now we want to get this by itself. And again, people say to combine this, but if I had 16 equals 9 minus 14x, you want to get the x by itself. So this is kind of like getting that cosine by itself. So we have to subtract that 9 in this case, subtract the 900. So we have 700 equals negative 1440 times the cosine of b, divide by negative 1440. So we have, I already forgot what it was, 700 divided by negative 1440. So negative 4.86 equals the cosine of b. And again, to find b, we do the inverse cosine, because we want to find that angle. So trig inverse cosine, we'll grab it, so 119 degrees. So if we put that in here, so this one is 119 degrees, we can use law of sines once again. The sine of 119 over 40, sine of a over 24, multiply times 24, and let's see what the sine of a is equal to. Pen's being awfully weird today. Times, so let's see, we got the sine of 119 divided by, what do we have there, 40.525. And then we have to do that inverse. So we can go to trig inverse, grab that, so we have 31.65, let's just round to 32 degrees. So we had 32 degrees, and then we can find that third one, 180 minus 119 minus 32. So we have 29 degrees. All right, and then the very last one that we're going to look at today. We have to find BC. Well, we could start here. We could do the Pythagorean theorem. So we got 6 squared plus 4 squared equals the hypotenuse squared. So 36 plus 16 is c squared. So 36, 50 equals c squared. And I see some roots here, so I'm going to leave that as the square root of 50. Then we have to find this other side. So Pythagorean theorem again, the square root of 50 squared plus b squared equals 10 squared. So you got 50 plus b squared equals 100. So b squared equals 50. So this side is the square root of 50 as well. And now we have to match it up with one of these. Well, I know it's not 6 and 8. And let's see. I totally messed up here, didn't I? This is 16. Well, that's going to throw things off. I was going to say, I don't think there's any of the answers here. So let's see here. 36 plus 16. And it's not, yeah, 36 plus 16 equals c squared. So we have 36, 46, 52 equals c squared. So now it's the square root of 52. Let's see if this changes things. The square root of 52 squared plus b squared equals 10 squared. So we got 52 plus b squared equals 100. So b squared equals 48. So this is the square root of 48. Nice thing about multiple choice, if we did it wrong, we can see that our answer doesn't come out there. Now, we could just type it in and see which one it matches up with. Some of you guys might remember, well, what two radicals multiply together to give us 48? Well, we could have 16 times 3. So this turns out to be 4 times the square root of 3. But if not, I would just type these in and see which one matches the square root of 48.